Good morning, my dear students. Today I am going to give the demo on queues. Today I am going to give the demo on queues. So before going to discuss queues, so these are the topics previous classes I covered. Okay, all of you. Your stack definition, array representation of stack, the stack abstract data type, applications of stacks. So what are the applications of stacks? Prefix, infix, and postfix arithmetic expressions, conversion evolution of postfix expressions. Last class, yesterday class, recursion and towers of Hanai problem I explained in previous classes. Clear? Today I am going to give the demo on queues. Okay, ma, all of you. Then what is stack? You know very well about stack. Then this is the example for stack. Then insert and delete operations done at only one end, that is called top end. The stack is called LIFO principle, last in first out principle. Then this is an example for stack. Then operations on stacks, there are three operations: push, pop, and display. Here push means insert, pop means delete, display means display all elements from top to bottom. Next one, using stack implementation using arrays and linked list. In this unit, we discussed using arrays. Then using linked list in third unit we will discuss. Okay. Next one is this is the using stack array. Next operations using array. Next one, push operation. This is called push algorithm. Okay, ma. Insert out, insert an element into the stack. This is an algorithm for push. Then this is an algorithm for pop, how to remove an element from the stack. Then this is display all elements from the stack. This algorithm is used to display all elements from stack. Then your stack applications. The first applications, expressions. What is an expression? An expression is a collection of operators and operands that represents a specific value. Then your operators, operator is a symbol yes or no. Operands are the values. Types of expressions. There are three types of expressions: infix expression, postfix expression, and prefix expression. Then infix expression. This is an example for infix expression. This is an example for postfix expression. This is an example for prefix expression. Then infix to postfix conversion. These are the steps to convert infix from postfix conversion. This is an example to convert infix expression into postfix expression. Then the infix postfix conversion using stack data structures. So this is an example for conversion. Okay, ma. Conversion, infix to postfix conversion using stack data structure. This is the given equation. The equation can convert from infix to, this is the postfix expression. Clear? So then these are all the steps. Next one, postfix expression evaluation. This is the postfix expression example. Then these are the steps to evaluate postfix expression. Then this is an example. 5 plus 3 into 8 minus 2 equal to 48 వస్తుంది. Yes or no? 5 plus 3, 8 plus minus 8, 48. 8 into 8 minus 2, 6. 8 into 6 equal to 48. Here 5, 3 plus 8, 2 minus asterisk. This is a postfix conversion expression. This is an infix, this is postfix. So evaluate using stack operation. 5, 3, 8. Then the next one, push on 8. 8 minus 2, 6. 6 into 8 equal to 48. Clear? This is an output. Next one is recursion. A function calls itself again and again until the condition becomes satisfied. When the condition becomes satisfied, the control exits from this loop. Am I right or not? A function calls itself. A function calls the same function again and again with the condition is satisfied. Clear? That is called recursive function. A recursive function, no need to use loops. In the recursive functions, no need to use loops. A function calls itself. So then until condition becomes satisfied. When the condition satisfied, then the control exit from the loop. Otherwise, the control infinite loop. Clear? This is an example program for recursive function to find factorial of the given integer. Next one, advantages and disadvantages. These are the advantages, these are the disadvantages. Program for towers of Hanai. So this is a small game, puzzle. So how many poles are there? Yesterday I gave example, 3 poles, 1 pole having 3 disks. There is no limit. If you want to increase the size of the disks, you can increase, no problem. But I gave only 3 disks. Then I want to move the same order from source to destination with the help of a temporary pole. Clear? So then this is an example program of this is the program for towers of Hanai problem, algorithm or program for towers of Hanai problem. Clear? Then the next one is what is QADT? So today's class, all of you clear? So come here, all of you. Then today's class is Qs. Simply, what is Q? What is QADT? ADT means abstract data type. Am I right or not? ADT means abstract data type. So QADT, abstract data type means set of values and set of operations is called ADT. Here in the Q is also having some operations and values. Clear? So we want to store some values in the Q and also we want to apply some operations on Q. That's why this is called QADT. ADT means set of operations and set of values. That is called ADT. QADT. It is also having operations and values. Clear? So what is a Q? What is a Q? For example, what is a Q? So we want to go to watch movie. Before going to watch movie, first of all we buy a ticket. Yes or no in the ticket counter. So first, so before start the show, we enter into the queue. Who will enter into the first? He is only the first person to enter into the theater. So next person, next enter. Next person, next enter. Last person, last. Am I right? So in the queue, all of you, in the queue operations, which is the first inserted element? So which is the first inserted element? That is only the first removable element. Which is the last inserted element? That is only the last removable element. Remember. So in stack operations, insert and delete operations done at only one end. That is called top of the stack. Am I right or not? Yes. So whereas in Q have two ends. First one is front end, last one is rear end. That is called rear, front is called front end. Clear? Here, removing elements from front end, then inserting elements from into the rear end. Clear? So here two ends available in the queue, front and rear. Front and rear. Rear means end, last. So then, so insert elements done at rear end, inserting elements done at rear end, removing elements from front end, removing elements from front end. Whereas in stack, insert and delete operations done at only one end, that is called the top of the stack. Then how many ends in the stack? Only one end. Whereas in the queue, how many ends? Two ends. The first one is front end, last one is rear end. Clear? So initially, first at the beginning of the program, initially rear and front equal to -1. So front and rear equal to -1. Initial value is -1. Clear? So come this. What is a queue? A queue is a linear data structure. A stack is a linear data structure in which the insertion and delete operations are performed at two different ends. Clear? Insert and delete operations performed at two ends. In a queue data structures, adding and removing elements are performed at two different positions. Clear? Adding and removing elements are performed at two different positions. So adding done at rear end, delete done at front end. Clear? In a queue, the insertion is performed at one end, deletion is performed at another end. In a queue data structure, the insertion operation is performed at a position which is known as rear end, last. So first I came, next you came, next your friend came, next your friend came, next your friend came. Then the last, the line goes to last at the end of the array. Clear? Then I am the first person. Am I right? I am in front. Next to you, next your friend, next your friend. Then rear end. So next anyone come, then he's also stand backside of your friend. Am I right or not? Then your insertions done at rear end, then deletions done from front end. Clear? So in a queue data structure, the insertion operation is performed at a position which is known as rear, and the deletion operation is performed at a position which is known as front. Clear? In queue data structure, the insertion and delete operations are performed based on PIFO, whereas in stack operations, LIFO, last in, first out. Whereas in queue operations, PIFO, first in, first out principle. Clear? Who will enter into the first, then he is only the first person to buy a ticket. Clear? Who will enter into the movie theater queue line? First, who will enter into the first person? He is only the first person to buy a ticket and enter into the theater. Second person, second. Third person, third. Fourth person, fourth. Until n minus 1. Clear? So then here is the performed based on PIFO, insert and delete operations performed based on PIFO principle. What is PIFO? First in, first out. First in, first out. Clear? All of you. So in the meal section, in the, for example, we want to attend a function or like marriage function. Then there is a buffet system. Then there is a queue. Who will enter into the first? He will take a plate, then collect food items, then eat first. Clear, yes or no? Then here also the same queue operations. So who will enter into the first is only the first removable person. Clear? So then in the queue operations performed PIFO principle, first in, first out principle. Clear? PIFO, first in, first out. So this is an example. This is an example for queue. So this is an array. All of it. So this is the front. First person came and stand here. Second person came and stand here. Then third person came and stand here. Next until last person. Last, the max size equal to n minus 1 until max size equal to n minus 1. Clear? In a queue data structure, the insertion operation is performed using a function called NQ. NQ means insert queue. Clear? So in a queue data structure, the insertion operation is performed using a function called NQ. So this is called insertion. And delete operation is performed using a function called DQ. Delete queue, insert queue. NQ, insert queue, insert an element into the queue. DQ means delete an element from the queue. Clear? Yes. So queue data structures can be defined as follows. Queue data structure is a linear structure in which the operations performed based on PIFO principle. Clear? So queue data structure is a linear data structure in which the operations are performed based on PIFO principle. We know. A queue data structures can also be defined as queue data structure is a collection of similar data items in which insert and delete operations are performed based on PIFO principle, first in, first out principle. Clear? So example, queue after inserting 25, 30, 51, 60 and 85. Which is the first element? 25 element insert into queue of 0 location. Clear? Next element is 30 insert into queue of 1 location. Then 51 insert into queue of 2 location. 60 insert into queue of 3rd location. And 85 insert into queue of 4th location. Here initially front and rear equal to -1. Then this is front, rear. First front to rear equal. Next insert at the 30 insert time, rear is incremented, front is constant. Clear? So at the inserting time, Rare is incrementing. Rare is incrementing by 1 itself. For example, I want to insert another element 90. So then 90 insert into q of rare plus plus. Q of plus plus rare. For example, now rare equal to 4. 4 plus 1 equal to 5. Q of rare equal to 90. Clear? So at the inserting time, rare value is incrementing. Clear? Rare value is incrementing. So operations on Q. So what are the operations on Q? We know the following operations are performed on a Q data structure. The first one is NQ. So to insert an element into the queue. Second one is DQ, to delete an element from the queue. Third one is display, to display the elements of the queue. So queue data structures can be implemented in two ways. They are as follows: using arrays and using linked list. In this unit, we are using queue data structure. We are implementing queue data structures using arrays only. Linked list in third unit we will discuss. Okay. When a queue is implemented using an array, that queue can organize an only limited number of elements. Stack is also same. Why? Using array, this is static memory allocation is done at the program writing time. We will assign memories. So we want to increase. Is it possible? No. So clear? When a queue is implemented using a linked list, that queue can organize an unlimited number of elements. Clear? Yes, using data structures linked list, we can increase the queue size. Whereas using arrays, then there is no possible to increase the size of the queue. Clear? That is fixed length. Then a queue data structures using arrays. So we know a queue data structure can be implemented using dimensional arrays, one-dimensional array. The queue implemented using array stores only fixed number of data values. The implementation of queue data structure using array is very simple. Just define a one-dimensional array of specific size and insert or delete the values into that array by using before first in first out principle with the help of variables front and rear. Initially, both front and rear are set to -1. Whenever we want to insert a new value into the queue, increment the rear value by 1 and then it insert at that position. Whenever we want to delete a value from the queue, then delete the element which is at front position and increment front value by 1. Clear? So this is before first in first out principle. So there are two ends, front and rear ends. Initially front and rear equal to -1, front end and rear end equal to -1. So whenever we want to insert an element into the queue, the rear is incremented. At the rear position, we will insert an element. Clear? So we want to remove an element from the queue. So front is incrementing. Front is incremented by 1 itself. Clear? So this is the data structure using array. Queue operations using array. So queue data structures using array can be implemented as follows. Before we implement actual operations, first follows the below steps to create an empty queue. So include all the header files, so which are used in the program, and define a constant size with specific value. Declare all the user-defined functions which are used in queue implementation. Create a one-dimensional array with above defined size into queue of size. Define two integer variables front and rear and initialize both with -1, int front equal to -1 and rear equal to -1. Then implement main method by displaying menu of operations. List and max suitable function calls to perform operations selected by the user on queue. Clear? Then the first one is inserting an element into the queue. This is an algorithm to insert an element into the queue. NQ. This is called NQ. Inserting value into the queue. This is an algorithm for inserting element into the queue. Clear, all of you? So here simply, so in a queue data structure, NQ is a function used to insert a new element into the queue. In a queue, the new element is always inserted at a rear position. The NQ function takes one integer value as a parameter and inserts that value into the queue. We can use the following steps to insert an element into the queue. The first step, check whether the queue is full or not. In stack operations, we are also checked the stack is full or not. So in which condition in stack? If top equal to max minus 1, the stack is full. Am I right or not? So here also, rare equal to size minus 1. Rare last position equal to size minus 1. Simply, so I mean the queue is full. Clear? The queue is full. Insertion is not possible and terminate the function. So otherwise, this condition is not satisfied. Then go to the else statement. So the queue is not full. Then increment rare value by 1, a rare plus plus, and set of q of rare equal to value. Then insert a value into the q of rare position. Clear? Rare equal to initial value minus 1. Minus 1 plus 1 equal to 0. Q of 0 equal to value. Clear? This is an inserting element into the queue. So this is an algorithm for NQ. Okay, ma? This is an algorithm for NQ. Clear, all of you? Next step, DQ. So deleting an element from the queue. So in stack operations, so in which condition the stack is empty? If top equal to minus 1. Am I right? If top equal to minus 1, the stack is empty. Come here. What is the changes made in queues? So in DQ means delete operation, deleting a value from the queue. In a queue data structure, DQ is a function used to delete an element from the queue. DQ is a function it is used to delete an element from the queue. In a queue, the elements is always deleted from front position. Clear? Insertions done at rear end, last end, rear end, or back end. Deletions from front end. Clear? The DQ function does not take any value as parameter. The DQ function does not take any value as parameter. We can use the following steps to delete an element from the queue. So this is an algorithm for DQ operations in queue. Clear? DQ means delete queue. Here click whether queue is empty. Simply check whether the queue is empty or not. If front equal to rare, if front equal to rare, like front equal to rare minus 1, I mean front equal to rare equal to minus 1, queue is empty. Am I right or not? Front equal to rare equal to minus 1, queue is empty. So then here simply both are minus 1, then queue is empty, then there is no element. Clear? That this is, so q equal to, so check whether the queue is empty. Front equal to rare, like rare equal to 8. So front is also 8, then there is no element in the queue. Clear? For example, rare equal to 4. Front is also 4, then there is no element in the queue. Clear? If it is empty, then display queue is empty. Deletion is not possible, and terminate the function from the algorithm. Otherwise, if it is not empty, then increment the front value by 1, your front plus plus, then display queue of front, that is deleted element. Then check whether the both front and rear are equal. If front equal to rear, if it is true, then set both front and rear equal to minus 1. Clear? And then that means then there is no element. Front equal to rear, then there is no element. Simply set positions beginning of the queue, minus 1. Clear? So this is the delete operation. Okay, ma. Next one is display operation. We know. So we want to display all elements from the queue. This method is used to display all the elements from the queue. We can use the following steps to display the elements of a queue. Check whether the queue is empty or not. If front equal to rear, then the queue is empty. So display queue is empty. Otherwise, if it is not empty, then define an integer value I and set I equal to front plus 1. Then display queue of I values, increment I value by 1. Repeat the same until I value reaches rare I less than or equal to rare last position. If I reaches last position, then stop the process until display 1 elements from the queue. So then these are the operations on queues. Okay, these are the operations on queues. Tomorrow we will discuss circular queues. Tomorrow we will discuss circular queues. Clear? Okay, all of you. I posted a second unit material in your Google class as well as WhatsApp group. All of you download and prepare well. Okay, all the best.